I'm Anil Kumar. Welcome to my series on calculus. Here is the very first quiz on Introduction to Calculus of one of my brilliant students. We'll share these questions with you and their solutions, and I hope that is going to help many students. So basically we have three questions here. All of them are based on rate of change, finding equation of a tangent line. And that is all about calculus, which we learn in the first part. So you can actually copy the very first question, solve it. Here is the second question now to share with you. I'll provide you with these solutions soon. And the third question is on the other side, which has three parts. You can copy these questions, answer, and then check with my solution. Here is a copy of these questions. Question 1 to 3. We'll go through these and then I'll provide you their solution. Question number 1. A circle is defined by the relation x squared plus y squared minus 4y equals to 165. Determine the equation of tangent line at the point 5, 14. Question number 2. Determine the equation of tangent line to the function f of x equals to x squared plus 4 at x equals to 1. Graph f of x and the tangent line. Question number 3. The revenue for selling x units of an item is modeled by r of x equals to 4 square root x, where r of x is in thousands of dollars. What is the revenue if 289 units are sold? What is the average rate of change in revenue when selling from 400 to 625 units? What is the rate of change in revenue when exactly 225 units are sold? Right? So you have to do this using the concept of limits. And that's why I've given the title Rates of Change Using Limits. So let's begin with question number 1. A circle is defined by the relation x squared plus y squared minus 4y equals to 165. Determine the equation of tangent line at the point 5, 14. Now, here we need to find first the center of the circle, right? So we know the circle. We need to find the center of the circle. Once we find the center, we'll find slope of the radius, and tangent is going to be perpendicular to it, right? So that is the whole concept. So knowing the slope of the radius, we'll know the slope of the tangent, and then we can find the equation, since we know this point, which is 514, lies on the circle. So first part is to find the center of the circle, which we can find by completing the squares. We are given the equation x squared plus y squared minus 4y equals to 165. To complete the squares, we need to add and subtract half of 4, right? Square, which is 2 square, right? So we'll add and subtract 2 square. And then these three terms will form a perfect square. So what we get here is x squared plus y minus 2 whole square. So minus because minus 4y and 2 from there. Minus 2 square is 4 equals to 165. Taking 4 to the right side, we get x squared plus y minus 2 whole square equals to 165 plus 4, or we get x squared plus y minus 2 whole square equals to 169. So that defines our circle, right? So for this circle, we have center at the point which is 0, 2, and we have a radius which is square root of 169 equals to 13, right? So we know now that this center is at 0, 2. Now that should help us to find the slope of the radius, right? So let's find the slope of radius now. let's call it O to P. So O is this point and P is a point where 514 is located. Now slope, as you know, from O to P will be y2 minus y1 over x2 minus x1. Substituting the values, we get 14 minus 2 over 5 minus 0, or is 12 over 5. Now, what is the slope of the tangent line? Well, slope of tangent, let's call it t, will be perpendicular, so it will be negative reciprocal, right? And this tangent will go through point P, which is 514. Now that should help us to get the equation of the tangent line, right? So now let's figure out the equation of tangent line. Now for this equation, we know that slope and point is given to us. We can use slope-intercept form, y equals to mx plus b. So we get, substituting the value of y as 14, slope m as minus 5 over 12, x as 5, we can find what b is, right? Now taking it to the left side, 14 plus 25 over 12 is b, right? So we get what? We get 12 times 14 plus 25 over 12 is b, right? Let's use calculator to find this value. So we have 12 times 14 plus 25 is 193. So we get the value of b, let me write down here. So we get the value of b as 193 over 12, right? So we now know the equation of the line, which is y equals to slope, which is minus 5 over 12x, plus b, 193 over 12. Right? So that is how we can answer this particular question. Is that clear? So I hope these steps are absolutely clear. The idea here is to find the center of the circle. For that, we needed to complete the squares. Once you know the center, then we find the slope of the radius, O to P. Slope of the tangent will be negative reciprocal, and that should give us, with this point 514, equation of the tangent line. So that becomes the equation of tangent line. Perfect. Now let's move on to question number 2. Question number 2 here is, determine the equation of tangent line to the function f of x equals to x squared plus 4 at x equals to 1. Graph f of x and the tangent line. So here we are going to use the concept of limits. Correct? To find this particular slope. So since we need to find slope at x equals to 1, let's find what is f of 1 equals to, right? If I substitute 1 here, we get 1 square plus 4, which is 5, right? Now, we need to find the slope, that is rate of change, instantaneous rate of change, as limit when h approaches 0 for f of a plus h minus f of a over h, correct? So that is the concept. So in our case, we are given a as equal to 1, right? So we can write this as limit h approaches 0, f of 1 plus h minus f of 1 over h. Now, f of 1 plus h is, substitute 1 plus h for x here, right? So we get 1 plus h whole square plus 4 minus f of 1 is 5 over h. Correct? So this gives us the value as limit h approaches 0. 1 plus h, let's expand this. We get 1 square plus 2h plus h square. 4 minus 5 is minus 1 over h. So 1 and minus 1 cancel. We are left with limit h approaches 0. So we have 2h plus h square over h. Right? Now, this particular, we could actually factor. Let me do it on this side. So we'll just take it on this other side. Okay. We can actually finish it here also. So we actually, or let's write down here. So slope m is equals to limit h approaches 0. We can take h common. And we have 2 plus h over h. So they cancel. Now when I substitute 0 here, we get slope m equals to 2. So slope of tangent line is 2 for us, right? We need to determine equation of tangent line of this function. So now to find the equation as we did earlier, we know slope m is 2 and the point is when x is 1, y value is 5, right? So 1, 5. Equation can be written as y equals to slope of m, which is 2x plus b. To find the value of b, we'll substitute the point 1 and 5. So we get 5 equals to 2 times 1 plus b, and that gives you 5 minus 2 equals to b, which is 3. And therefore, we get the equation as y equals to 2x plus 3. Correct? So it's a line with slope of 2x and y-intercept of 3. Now, second part of this question is to graph the function and the tangent line. It's a parabola which is opening upwards. So let's I'm making a rough sketch here. You need to do a better job. Everything is on the top, so I'll just use x-axis right there, right? Okay. So the function here is 4 is the y-intercept, 1, 2, 3, 4, okay. And it is going by 1 and then 3, 1, 3, 5, 7 steps, correct? So I hope you understand this process. So, okay, so we have this parabola. So let me join this using a curve. So that is the parabola which represents the function f of x, correct? Now, the point given to us is at 1, we have this value 5. Slope at this point we figured out is 2. So we go one step here and 2 up, right? We can go one step on the left and 2 down, right? So that gives you the tangent line. So use a ruler to draw this tangent. However, here is how it is going to look. Do you see that? So that is how we can actually sketch the tangent to the parabola, correct? So I hope it makes sense. This point here is 1, 5, okay? And this intercept is at 4. And the line which we have drawn is y equals to 2x plus 3. Perfect. So that is how you're going to complete this question. So I hope each and every step is absolutely clear. Now let's take up the last question. Question number 3. The revenue for selling x units of an item is modeled by r of x equals to 4 square root x, where revenue is in thousands of dollars. A. What is the revenue if 289 units are sold? So let's calculate this. So part A, revenue for selling 289 units. We need to substitute 289 for x, so 4 square root of 289, correct? So that is how you can figure this out. And our square root of 289 is 17, so we get 4 times 17. And you can now multiply by 4. 4 times 7 is 28, 8 and 2, 68, right? So we get revenue as 68. Now, as it is given here, r of x is in thousands of dollars. And therefore, our answer should be written as revenue is in dollars 68,000, correct? So that is important to write. Now let's do part B, which is based on average rate of change. What is the average rate of change in revenue when selling from 600 to 625 units? So average rate of change is equal to revenue for higher value, which is 625, minus revenue for 400 divided by 625 minus 400. Clear? So that is what it is. So we'll just substitute the values. So we get 4 times square root of 625 minus 4 times square root of 400 over this difference, which is 225. Well, 4 is common, so we can just take 4 common. 625 is 25, right, minus 20 over 225. So we get 4 times 5 over 225. Now that can be simplified. 5 times 4 is 20, 45, correct? So we get average rate of change as 4 over 45. Now, in the numerator is revenue, right? Thousands of dollars, right? So it is thousands of dollars over per unit sold, correct? So that becomes the unit for the average rate of change. Is that clear to you, right? So that is how we are going to solve this question. Now let's move on and see part C. So question number 3, part C is, what is the rate of change in revenue when exactly 225 units are sold? That means we are interested in finding instantaneous rate of change, right? So I, instantaneous rate of change, right? Now instantaneous rate of change can be given to us by, we want when the sales is of 225 units. So f of a plus h minus f of a and over h. Of course, limit when h approaches 0, right? That is when we get instantaneous rate of change. Now substituting the values, we get limit h approaches 0, f of a plus a. Function is f square root of 4 square root of x. So 4 square root of x 225 plus h, right? So a is 225 minus 4 times square root of 225 over h, right? So that becomes the expression for instantaneous rate of change, right? So we call this as difference quotient equation. For instantaneous rate of change, correct? So using this equation, we can now find the solution, correct? So to simplify, 4 is common. Let's take 4 outside. So we can rewrite this. Instantaneous rate of change is 4, I'm taking constant outside. So we're left with limit h approaches 0. And we have square root of 225 plus h minus square root of 225 is 15, right? Over h. Correct? So we get this equation. Now we need to rationalize this. So we get this as 4 limit h approaches 0 square root of 225 plus h minus 15 over h times, to rationalize we'll multiply and divide by its conjugate. So we get square root of 225 plus h plus 15 over square root of 225 plus h plus 15. Correct? So that gives you 4 times limit h approaches 0, difference of square, which is 225 plus h. Now we get minus 15 square, right? So we have 15 square, which is 225, over h times square root of 225 plus h plus 15. Now h and h cancel, so we are left with 4 limit h approaches 0. 225 minus 225 is 0, h and h cancel, so we have 1 over square root of 225 plus h plus 15. Correct? Now substituting h, we get our instantaneous rate of change. So we get instantaneous rate of change as equal to 4 times limit h approaches 0. Now of this particular expression, so let me just copy it. 1 over square root of 225 plus h plus 15. When I substitute h as 0, I get this as 4 times 1 over square root of 225 plus 15, which is equal to 4 times 1 over 15 plus 15, correct? Which is 4 over 30, or 2 over 15, correct? So we get 2 over 15. The units of instantaneous rate of change will be dollars in thousands, right? So we get dollars in thousands per unit. Correct? So that is what we get as instantaneous rate of change in the given example. So I hope with this you understand how to solve this test paper. Feel free to write your comments, share your views. And if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.